Welcome to Water, the podcast. If you work in water, whether it's treatment, distribution, wastewater, or management, this podcast is for you. In each episode, you'll hear a unique story and gain fresh insight from a colleague inside the water industry. Here's your host, filmmaker and municipal operator, John Parsons. Enjoy this episode.
Welcome to the podcast, Water, and I'm John Parsons again. And I have a wonderful guest here today. I've got Titus, who is the Vice President of Operations of Titus Wastewater Solutions, all the way from Casper, Wyoming. So, Lewis, it's an honor to have you on the show. Thank you for coming.
Oh, thank you for inviting me, John. It was good to meet you up in Bismarck, North Dakota this year, and looking forward to doing your podcast.
Yeah, I was real interested in our conversation. Of course, there's lots of things that were interesting, but you do have some fascinating pieces of equipment, and I'm really kind of interested in your story, Lewis, as to how you got into the water industry, because the water industry, we've all got our unique story of how we got here or what brought us in here. But you've got some unusual pieces of equipment that have some, I looked at some of your videos, and you've got some pieces of equipment that have got some unique features. So I'm kind of curious as to how you came up with those features and how you got into it. So tell us a little bit, if you would, of your story of how you got into this business.
Well, it's kind of a long story. I went from being a pipeline mechanic for Pacific Gas and Electric gas transmission to starting my own business back around the turn of the century. I like to say that. Makes me feel old. And anyway, we were a rep company for many years, and we got involved in the wastewater business early in our career after I left the pipeline. We started basically a business from scratch, me and my wife, back in Oregon. And we represented a lot of different companies, a lot of different products. And so I dabbled in some other aeration devices by some other manufacturers, and never was very satisfied with any of it. I thought all of it had a lot of shortcomings. And we decided about 5-6 years ago to step in the manufacturing world, and we went out and redesigned a bunch of equipment and got a number of patents, and off to the races we went. And we think we've really solved a lot of the issues in the wastewater business, both on the pretreatment side for addressing fats, oils, and greases and odor control. We specialize in using ozone. That's one of our pieces of equipment. It's called the Titus Twister, and we've taken the ozone industry to the next level. We've simplified it and made it much cheaper, much more reliable, and much more powerful. So we're able to do some pretty interesting things with that. And with that said, I was working with some engineers when COVID first hit, and they really liked my small twister unit, which typically goes in a sewage pump station. And they said, well, what do you got for lagoons? And I said, well, I don't have anything right now, but I got one up here. I've been thinking about this for a long time. And that was the week when COVID hit Bothell, Washington, and killed all those people in the old folks' home. And that was literally the last trade show for like 3 years where I met this engineer. The engineer was with an energy engineering company, and their whole thing was coming up with ways to reduce power consumption for utilities mostly. And if you go to any place that's got aeration, their number one expense in wastewater treatment is aeration. It costs a lot of money for the equipment and a lot of money for the power to run the equipment. And so they're always trying to come up with better ways of doing it. And lagoons in particular, the technology for lagoons most of it's 75-year-old technology. Most of it's an electric motor with a propeller on it, or it's a bottom diffuser. It's kind of one of the two. And both of those have a lot of drawbacks. And so long story short, I had an idea in my head, and me and my crew spent about 3 years working with scale models and then the larger models. And then I had to jump in the water and spend a whole lot of money to build rotational molding equipment to rotomold the full scale floating aerator. which I think is your main interest today. And so we got that done, and then we spent several years doing field trials, field testing, and refining the equipment. We hired Redmond Engineering out of Wisconsin, who did all the energy efficiency testing, which is the main thing that engineers all worry about is how many pounds per horsepower hour can you transfer into water. That's the big number. And I try to educate the engineering community that that's half the equation. That's the only half most of them ever look at. But the other half of the equation is how much water can you move per horsepower hour, which is your mixing efficiency. And so we set out to build a unit that was way better at mixing, and also had excellent oxygen transfer efficiency. And then one of the other factors was cold weather performance, which John, you're in North Dakota. First time I met you, it was like 15 below zero up there. And it gets very cold. And so we designed a piece of equipment that will operate even in extreme cold. We've had them running at 44 below zero with no issues whatsoever. So we've accomplished a lot of things that we didn't think we could even accomplish with one machine, and it's been a great success. So that's a little bit of the history of how we got into it.
Yeah, thank you for sharing that. When I looked at the equipment that you have in one of the videos I looked at, with this machine was working in Idaho, and I'm like, okay, all right, if they know how to work in Idaho, their stuff will work over here in North Dakota. So that caught my attention. And then of course the other part that caught my attention was that you don't actually have the electric motor and everything is not on the unit. You've got that on shore. And I thought, boy, this is fascinating. This is a very interesting way of approaching things. So that caught my attention because, of course, as soon as you've got an electric motor floating out in the water, you've got other issues to deal with. And so that was fascinating. But I'm really interested in the fact that to me, when you tell me that story, I see this is a hands-on. This is an inventor. You're an inventor, but hands-on. I mean, many of us in this industry are hands-on people. We work, we fix. We're not afraid to pick up wrenches and fix things and do that kind of stuff. Although we've also got to run computer systems and all the rest. I mean, it's not non-techy, but that intrigues me about your approach to it. So I think a lot of people can identify with that kind of approach. I mean, operators who are dealing with stuff, we've got to have to fix things all the time. So this is great. So, what brought you to the idea of not putting the motor and everything on the unit?
Well, putting electric motors out in a wastewater lagoon is problematic. They don't last very long. Anytime you have 480 volt power out in a lagoon, in my view, it's a big safety hazard. And the maintenance, nobody wants to do boat access maintenance on an aerator. And, we're in human waste. Typically, we do a lot of industrial waste, which is, in my view, is even nastier. But to go out in a boat and have to grease these things and derag them, anytime you have a propeller on a unit, it's prone to ragging up. And so, we tried to eliminate all those from a safety standpoint and from a maintenance standpoint in general. So our aerator is basically maintenance free for about a 10-year period. And at that time, we would probably pull it out, which requires a crane, and disassemble it and replace the diffuser. It does have a diffuser. And so the two basic kinds of aeration systems are bottom diffusers, and there's a number of different diffused air systems, but they all do the same thing. They got some sort of a diffuser and it sits on the bottom of either a tank or a lagoon. That we see in both places. And then the other type is a mechanical aerator, which typically there's two types. Aspirating aerators, they draw air down a hollow shaft, and they have an electric motor mounted on a pontoon, and it's at an angle, and they spin a propeller, and as they draw the air down the shaft, it chops the bubbles up into finer bubbles. And that's all done basically just below the surface. And what they try to do is they try to drive bubbles down in the water, which is impossible. You cannot drive bubbles down in the water. They'll go down a few inches, but they go right back up. But what we have discovered is if you have high DO water, in other words, the oxygen is dissolved into the water, you can drive it right to the bottom of the pond with no problem. So basically, that's what our machine does. The other type of mechanical aerator, again, is electric motor with a propeller, and it throws water up in the air. It's spectacular looking. They look pretty cool. Some of the issues with that is they don't work very well in Bismarck, North Dakota when it's 40, 50 below zero because water freezes very rapidly when you throw it in the air. And so typically you don't see that type of technology north of the Mason-Dixon line. Let me rephrase that. You should not see that technology north of the Mason-Dixon line. Unfortunately, I do see it up here, and it almost never works. It never works correctly. It is a more efficient way of doing it than the aspirating aerators. The aspirating aerators are about 1.1 pound per horsepower hour efficiency. If you turbocharge it, in other words, you put another electric motor out there with a blower and you blow air down that shaft, you can get them up to 1.6, which is about a 40% improvement. The high-speed surface aerators come in at about 1.8 pounds per horsepower hour. Our technology comes in right at about 2 pounds per horsepower hour. So as far as floating aerators, we're the most efficient of the bunch as far as transferring oxygen. You cannot rag our units up. They're rag proof. And I've had a lot of people just swear that there's no way we could run these in their ponds because their ponds were completely full of rags. Makes no difference. They handle rags like they're nothing. So we eliminate that maintenance problem. And we use a membrane diffuser that has about 40,000 tiny slits. They're slits, they're not holes. And a slit will open and release a bubble and close behind it so they don't foul. So it eliminates the cleaning issue. Fixed pour diffusers, they plug up. And part of the problem with bottom diffusers, and all these aeration systems, all of them have one type of problem or another. Bottom diffusers, you can run them in cold weather. They'll run in cold weather just like mine will. The problem with them is they sit in one place, and I don't care how many of them you put in. After a few years, they're completely buried in sludge. And what happens is they start plugging up and your pressure starts going up and your efficiency starts dropping off. Your DO levels go to hell. And pretty quick, you're not meeting your discharge limits. And so it's always been a big problem with bottom diffusers. And mechanical aerators, they sit in one place because they either have rotational torque, high-speed surface aerator, you got electric motor spinning a propeller in the water, that motor's trying to spin the other direction. So to anchor that, they either put pipe stanchions in and anchor them to them, or they put cable systems in to control that rotational torque. Either way, that machine doesn't move. It sits in one place and it drills a hole down through the bottom of the pond. It can damage especially if you have a clay liner, you don't have a membrane liner, you can actually do a lot of damage with those things. But they sit in one place, they don't move, and they deposit sludge all the way around them. And so I go to lagoons with these high-speed surface aerators, and they'll be. I just did a project. The lagoon was 10 feet deep, and there was 10 feet of sludge in it. They spent $2 million dredging that lagoon. $2 million. And it's not even. It's a good-sized lagoon, but it's not all that big. So engineers look at pounds per horsepower hour. They don't look at mixing efficiency. Mixing efficiency is what gets rid of most of that sludge. And that is probably a bigger cost than the energy to run the aerator. So if you can get rid of, and typically with our equipment, we can get rid of 50, 60% of the sludge pretty easy. We can drop it right into an existing lagoon without having to dredge it and reduce that sludge layer about 50, 60%, sometimes more than that. It's all based on the volatile versus non-volatiles. The volatile solids are the stuff that's organic that will still break down. The non-volatiles is the stuff that's completely broken down. It's like a pile of ashes. You can't burn ashes up anymore. So what we're trying to do is decrease the percentage of volatiles and increase the percentage of non-volatiles. Eventually, the non-volatiles have to be removed, but if you can extend that dredging frequency, say from 5 years to 15 or 20 years, the cost savings is absolutely enormous. It's absolutely enormous. And that's really what we're trying to do. Our equipment, we use airlift technology. So we have a diffuser, which is a pipe inside of a bigger pipe. It's got a very large diffuser with about 40,000 slits in it. As we release that air, the bubble goes up, and it's going up in a toilet bowl fashion, which keeps the bubble in the water longer. The longer you keep the bubble in the water, the more oxygen you can transfer, the better your efficiency. All that goes up, and that water hits a specially designed head that's full of dock foam. It floats, and it's actually partially submerged. We use 2,500 pounds of concrete in the bottom to pull that head partially underwater, and we discharge that water out through a slit about 3 inches thick, and it's going out at very high velocity, and it's going out at about a 15-degree angle, and that is the high DO water. So if we bring low DO water in from the bottom, we transfer oxygen all the way through the machine. We increase the velocity of that water going up through the machine. It hits the head, it splits it, and it exits at 15 degrees. So we're constantly turning the entire pond. And one of these units will mix a very large pond. It's amazing how big an area it will affect. It's incredible because it moves a lot of water, and it does it cheaply. And with a subsurface discharge, one of the other problems I eliminate with high-speed surface aerators, when you throw water up in the air, they vaporize, and the wind catches that. And if you're in an area that's got homes around, the smell is not good. So odor control is a big deal. It's not just freezing. When you throw it up in the air, it freezes. It also stinks. So we discharge subsurface. Part of our patent is a subsurface discharge. It doesn't look as spectacular. What you do see when you're looking at the videos, and I encourage everybody to go to my YouTube site. There's some really good videos. And John may add one onto this when he does the final edit on it. What you're seeing is the spent bubbles that hit the head that roll out around the head. You're not actually seeing that jet of water coming out of this. You would literally have to stand on top of it to hold your hand down to feel that jet. So it's 360-degree discharge. There's no rotational torque. There's no thrust. Aspirating aerators have thrust. It's like tying a boat to the dock and running your outboard wide open. That's basically what it is. And again, that's a lot of thrust, so you have to contain that. So they don't move. Nobody ever moves them. So they sit in one place. They got one small mixing area. Sludge builds up all the way around them. And keep in mind that sludge reduces your solids residence time. So in other words, the BOD coming into that water needs a certain amount of residence time to get treatment. Well, that's based on the gallons of that lagoon, basically. And as the sludge gets deep enough, you will short circuit. The water will go out the discharge before it's had enough residence time to actually break that stuff down. So you got to keep your sludge layers to a minimum, and that increases your SRT, your solids retention time.
So just to be clear, Lewis, your machine moves according to the tether that it's on. It can move. It's free to move around the pond according to the length of that tether that it has, right?
The length of the tether, and you can tie this off to a T-post. So if you got a lagoon, it doesn't cost a lot of money to put an anchoring system in. I can walk around a pond and drive in $5 T-posts and tie them off to a T-post. That's all it takes. It's a half-inch piece of rope. So you can constantly move the tether. You leave a loose tether and enough hose to let the wind move it around. But what we're trying to do is increase the area of influence, if that makes sense. The bigger the area of influence. Now, there are some ponds where we don't want to do that. And for instance, facultative lagoons, which are typically very large, very, very large footprint, they typically don't have a big sludge load. They'll generally have under a foot of sludge in them. And that's actually anaerobically breaking down because there's no oxygen on the bottom. And the way a facultative lagoon works, it works off of the wind. The wind transfers oxygen that's on the surface, and also algae. Algae grows in these lagoons. In the sunlight, it produces oxygen through photosynthesis. At night, that kind of shuts down, and usually the wind dies down. And a lot of times they will go to zero or close to zero DO levels, which allows them to denitrify, allows the bugs to go after the nitrogen. And so it's pretty cool how they work. The problem with a facultative lagoon is, if you got 1,000 people that it was designed for, and all of a sudden you've got 3,000 people living there, the community's gotten bigger. And then you bring an industrial load, say a meat processor comes in, or a winery comes in, or any kind of industrial load, pretty quick they can't keep up. And so then they have to augment that with aeration. And what we make special units just for that. And we have what we call a side intake unit. And it will go in, and instead of pulling up all that sludge and resuspending it, we pull the water in sideways, and we aerate the water top to bottom, right down to the sludge layer. But we maintain a high DO level right down on top of the sludge layer. That allows the bacteria to eat the sludge from the top down and anaerobically eat it on the bottom. So we actually attack the sludge two ways on these facultative lagoons. So
can you give us a case study or two just of units that you put in different places?
Yeah. Oh yeah. We do both municipal and industrial. So on the municipal side, I'm working with the city of Carlton, Oregon, and they were looking at putting in, they hired an engineering company that recommended 24 aspirating aerators. And the city manager said, there's no way, I don't want 24 mechanical aerators. I don't want the maintenance. I don't want the cables all over my pond. I don't want the SO cord all over my pond. Got to come up with something better. And he found out about it. We'd literally just launched this equipment at that time. And these ponds were 350 feet wide and 1,300 feet long. They're very large, basically facultative lagoons. The town was originally designed, the system was designed for 1,000 people, and now it's 2,500 people. A meat processing plant went in, then a winery went in, and now they're expecting 4 more wineries. This is in the Willamette Valley of Oregon, around McMinnville, where all the wineries are. So now it's a big industrial facility. We initially went in with 1 4-foot side intake aerator, and we installed it, and they were literally running the aerator every other day. They'd run it for a day and shut it off for a day, because one aerator, we were getting a lot of facultative action, and all we had to do was boost it to get it up enough to handle the extra load. And but we were running 7 milligrams per liter DO one end of that lagoon to the other, running every other day. It was pretty amazing. They were dumbfounded. Pond was 7 feet deep, and we had DO right to the bottom and all the way 1,300 feet to the other end of it. Now they got 3 more wineries coming in, so they just purchased 2 more units, and they're doing it proactively because they don't want to be out of compliance again. But some of their issues were algae, which algae produces oxygen, but it's also TSS, it's suspended solids. And so a lot of places, a lot of lagoons, they have to filter that. And again, now you're talking a lot of maintenance. The filters are constantly plugged up with algae. When you put one of our machines in, it moves huge amounts of water. Algae does not like moving water. And so it doesn't kill it, it just doesn't grow. It'll eliminate about 80 to 85% of the algae growth in a lagoon. And then we augment the oxygen the algae produces by obviously mechanically putting in DO. So we eliminate the algae problem of TSS and increase the biological action with high DO levels. And it's fully adjustable. The units, they're putting 2 more units in now. They're all on DO probes. They're all on VFDs, so we can ramp them up, we can ramp them down, we can turn them on, we can turn them off. We run 1 unit, we run 4 units. So everything's very versatile system. And again, everything's able to move around.
So as far as people finding out, you've got videos and stuff that people can look at, and you've got a website. I think your website's Titus, wws.com, but is there another place where people should go to look at some of these things, Louis?
You go to YouTube and type in Titus Wastewater Solutions YouTube, That will take you to our YouTube channel. And there's all kinds of videos on there, both of our pieces of equipment. The installation you're talking about in Idaho, there's a commercial installation, a meat processing plant. And unlike McMinnville or Carlton, Oregon, their problem there is cold. Twin Falls gets extremely cold, so in the winter they'd have to shut off their units, and it just wasn't very efficient. We put 1 6-foot twister in and replaced 4 mechanical aerators, 2 aspirating aerators, and 2 high-speed surface aerators. So they'd run the aspirating aerators in the winter when it got real cold, because they will run in colder weather than a high-speed surface aerator. They're not near as efficient though. So we eliminated all 4 of those with 1 machine. There's a really nice video on the YouTube channel that shows complete. It's about a 2-hour job to put one of these in start to finish. You don't have to drain the pond. You don't have to put any kind of special tie-ups. Again, you can take a T-post and drive it in. This particular one, they set it on a concrete pad, but we have other ones where they actually mount the blower on a cart that they can pull up and down the dike. And that gives us even more freedom of movement to keep that thing, again, increase our area of influence. So a lot of different ways to do it. We run PD blowers. Right now, we run our little bit about our blower package. I spent a couple of years figuring out the most efficient blower package. And we ended up with PD blowers because they'll run at real low pressure. A lot of people don't like them because they're noisy, but we have a sound attenuation unit that gets them down to about 75 dBs, which is really pretty quiet. But they're super efficient. High-speed turbo blowers and some of the other blower technology will not run at the low pressures that we're running. We're typically running anywhere from 2.3 psi up to a maximum 4.5 psi. PD blowers are designed to run up to 15 psi. So when you're running at that low pressure, you're not generating the heat, and the blowers last much longer. One of the complaints with PD blowers is longevity, and that's mostly due to trying to overcome 12, 15 feet of head pressure and the heat generated by that. So with a floating aerator, we just don't have that problem. If we're in real deep water, we can add draft tubes. So say if you're in 20 feet of water, you want to pull water off the bottom, we bolt a draft tube up to the bottom of this thing. We make these in 3 foot, 4 foot, 6 foot, and 8 foot. That's the height of the unit. The deeper the pond, the taller the unit. And the further we push the membrane diffuser into the water, the further down the diffuser is, more oxygen we're going to transfer with a single unit. So my 8-footer will transfer more oxygen than my 4-footer, for instance. Efficiency, however, is pretty close to the same. They all run about 2 pounds per horsepower hour, which is, again, that's as good as there is in the industry as far as floating aerators go.
So, of course, people always ask the next question, and that's about service and support. Obviously, you're there, but tell us a little bit about how that works. If people have issues, problems, how do you fix those?
Well, we're always available. You can call me anytime. I have about 16 rep companies around the United States, including Alaska. And so pretty much everywhere we go, our most of my reps are pump companies. They sell pumps for sewage pump stations and whatnot. So they have service departments. They got service trucks. They got electricians. So they're fully capable of coming out and doing any type of service. With that said, there's not much to service on these. The blower packages are direct drive. We use what we call run slow technology. I use an oversized blower, and we run it about a third of its rated capacity. That extends the life of it dramatically. It quiets it down, and it's the most efficient system we found as far as pounds per horsepower hour, which is the number one thing that engineers worry about. Super efficient, quieter, and we fully expect to get 20, 25 years out of these blowers, mainly because the temperature, you can lay your hand right on them when they're in operation. They just don't generate much heat. Heat is the enemy of a blower. And again, with no belts, there's no belt maintenance. The maintenance on this is 2 grease zerks and a half a quart of oil. That's a quarterly. I recommend you grease them once a month. It's 2 squirts of grease, so it's literally 1 minute. And then change the oil takes about 10 minutes, and that's quarterly. And the air filter is probably on a quarterly basis as well. A lot of it depends on what kind of environment it's in. If you're out in farmland, it's really dirty. Air filter maintenance is going to be more frequent. So that there's a variable there. But the big thing is all that maintenance is done on the bank. There is no maintenance out in the water. It's a air hose goes out in the water. That's it.
I like that idea. That idea I like a lot.
Everybody likes that idea. So basically what we have is a bottom diffuser, a very efficient bottom diffuser. We mounted it on a float so it doesn't get buried in sludge. Bottom diffusers can be very efficient at transferring oxygen until they're buried in sludge. And so all those problems go away.
Well, Lewis Titus from Titus Wastewater Solutions, this is fantastic. Really appreciate you coming on today. Is there anything else you'd like to tell us? How best people should get in touch with you guys? Any of that information you'd like to put out there?
Yeah, you go to the website. You can call us directly, and we'll put you in touch with one of our reps. But we can help you size your system. I have a PhD wastewater engineer on retainer that can help me with sizing these. One little piece of advice I would like to give everybody here, and unfortunately, I've seen this. I've seen this actually up in North Dakota, and it really makes me sick. Where some not so honest people went out and put aeration systems in without doing the arithmetic. And when I say that, when you got wastewater, you've got CBOD, municipal, it's mostly BOD. It takes so many pounds of oxygen per pound of BOD. And it's a simple formula. You can do the calculations. It will tell you how many pounds of oxygen is going to be required to maintain your DO levels. If you have somebody come out there with a system and they don't do those calculations, and if they do not have test data from someone like Redmond Engineering does clean water testing. Clean water testing tells you exactly what your equipment puts out for oxygen, how much it transfers, and it's done in clean water so they can compare everybody's equipment side by side. If they do not have that test data, and I'm telling you, there's a lot of them don't have it, just walk away from them. You're going to get in trouble. I just seen a system up in North Dakota, and they've spent several $100,000 on a system that then they got zero. And two different manufacturers, neither one of them went through the numbers with them. So my recommendation, and again, I have a PhD wastewater engineer on retainer. I can bring him in to do your calculations. If you have your own engineer, they probably know how to do that. Not all of them do. Some of them do. And make sure you factor in an alpha factor, that's your oxygen demand plus the loss of efficiency because it's wastewater. There's different things in wastewater that reduce the efficiency of aeration. All that has to be factored in. And you really need to have this done. And I can't stress it enough. I'm really tired of seeing people getting taken advantage of by somebody just trying to sell a piece of equipment. You go through us, we're going to size it for you. It will be amply sized. You will get plenty of DO, and we guarantee that.
That's fantastic. Now, I know you're a little bit of a hunter here, so we better just say something about that because I know a lot of people are very interested in that subject. So we got to just touch on that topic. Talking to me from Wyoming, we got to touch that.
Well, my daughter does outdoor television, so she's got a podcast. She's got a lifestyle show, and she's also got a TV show on the Pursuit on the Pursuit channel. It's called Pursue the Wild. So if you're interested in hunting, go watch Pursue the Wild. I'll give her a shameless plug. And once in a while, I even go hunting with her. So I get to go kill something once in a while. We have a lot of fun.
Thank you for sharing that. Thank you so much. Lewis Titus from Titus Wastewater Solutions. We really appreciate you being on with us today. Thank you.
Thank you, John. I appreciate the opportunity. One other thing I would like to, could I touch on one other thing? We've been talking about lagoons with this technology. We've taken it way past lagoons now. So we're into mechanical plants now, which typically you don't see floating aerators in their aeration basins. But one thing we've discovered that these things are really good for big scum pits. because they'll work in real thick sludge, and they're also good in EQ basins. Again, you eliminate mechanical mixers in EQ basins. You got an air, there's nothing to wear out in them. And the third thing that we're working on right now is actually using them in mixed liquor aeration basins. And we're looking at using them to keep the arrays of 9-inch discs, which in an aeration basin, they typically have the bottom of the tank is covered with 9-inch EPDM membrane discs. That's where the aeration comes from. Again, they're fixed and they fill up with, eventually the sludge builds up, and they got to pull all the water out of that, transfer it to another tank, and go in and clean all those things. And you can add one of our floating aerators, and we can adjust the suction to work right over the top of those discs and help keep them clean, keep that sludge pulled up out of them, and extend that maintenance frequency. So we're no longer just about lagoons. Big tanks, even if you're in big city, if you're watching this, and I'm working with a big city, one of the big cities in Nebraska right now, we're looking at actually putting a floating aerator in their influent pump station, because it's 25 MGD pump station. It's very large, and so it's big enough to put a floating aerator in, which will keep all that mixed and give them some pre-treatment. So it no longer just for lagoons. So I wanted to throw that in.
Thank you for doing that. It's a little extra food for thought there. Thank you. That got me thinking too. So appreciate that. Thank you so much, Louis. Thanks for being on with us.
Well, thank you, John. Appreciate the opportunity, and we'll see you next time.
You have been listening to Water, the podcast, with filmmaker and municipal operator John Parsons. Subscribe via your favorite podcast platform. If you'd like to be a guest, or if you need a film or video to communicate your message, find us at waterthepodcast.com.